In this video, we're going to learn all about how to add and subtract rational expressions. So our first step will always be to factor the denominators of each term. Then you're going to find and rewrite each term in terms of the LCD, or least common denominator. After that, you'll be able to combine the numerators and simplify whatever is left. Let's take a look at this problem to get started. 5 over x squared minus 9 plus 3 over x squared plus 2x minus 3. Again, we want to start by factoring the denominators. We're going to start with x squared minus 9, which is a difference of squares, and we can write it out as x plus 3 times x minus 3. Now for our second denominator, x squared plus 2x minus 3, I need to find two numbers that multiply to negative 3 and add to 2. When I do that, I'm going to be able to find x plus 3 times x minus 1 is the factored form of that denominator. So now I'm rewriting this with those denominators factored out. And now I want to find the least common denominator. So I write out each set of denominators and I try to see what's the same. So they both share an x plus 3, so I'll carry that down. And then I'll also carry down 1x minus 3 and 1x minus 1 to find that LCD. Now I need to rewrite each of these terms, these fractions, with that LCD. Now what's missing from the first fraction's denominator? Well, that would be the x minus 1. So I'll multiply by that on top and bottom. For the second fraction, I'm missing the x minus 3, so I'll multiply by that on top and bottom. Once I do, I'm going to be able to distribute the 5 in the first numerator and the 3 in the second denominator. So now that I have this set up, I have two fractions with the same denominator. I can go ahead and combine the numerators. 5x minus 5 plus 3x minus 9 becomes 8x minus 14 once I have combined like terms. The very last thing I need to do is simplify. In this case, it is a little bit simpler to have a multiplied out denominator. So I'm going to start by doing x plus 3 times x minus 3, which is x squared minus 9. Then I'm going to FOIL out x squared minus 9 times x minus 1, which gives me x cubed minus x squared minus 9x minus, plus 9 in the denominator. All right, so that was my addition example. Let's take a look at a subtraction example. Let's say I give you 10x over x squared minus 6x plus 8 minus 2 over x squared minus 4x. Again, I want to start by factoring the denominators. When I have x squared minus 6x plus 8, I need to find two numbers that multiply to 8 and add to negative 6. Those two numbers are going to be minus 2 and minus 4. So my factored form is x minus 2 times x minus 4. On the other hand, x squared minus 4x has a greatest common factor of x. So I'm just going to pull that out and be left with x minus 4. So I rewrite these two fractions with their factored denominators. Now I'm going to find that LCD. When I write this out, I'm going to see that my LCD is x times x minus 2 times x minus 4. Now, the first fraction is missing the x, so that's what I'm going to multiply by on top and bottom. The second fraction is missing x minus 2, so I'll multiply by that on top and bottom. Then in my first fraction, I'm going to do x times 10x is 10x squared, and 2 times x minus 2 is 2x minus 4. Now, in order to combine these numerators, I am going to need to put the 2x minus 4 inside parentheses and then distribute the negative. That's going to give me 10x squared minus 2x minus 4 in the numerator. To finish simplifying this example, I'll just need to multiply out the denominator. I'll start by distributing x to x minus 2, which gives me x squared minus 2x. Then I can FOIL x squared minus 2x and x minus 4. First gives me x cubed, outside is minus 4x squared, inside is minus 2x squared, and last is plus 8x. I just need to combine the like terms and then I will be done. So when I see minus 4x squared and minus 2x squared, I'll combine those to give me minus 6x squared. This gives me a final answer of 10x squared minus 2x plus 4 all over x cubed minus 6x squared plus 8x. And that is how you add and subtract rational expressions.